Hello, hi, and welcome to today's video. In this lesson, we are going to learn about SCL programming, and specifically, we will focus on the while do loop. This is the second type of loop we are learning. In our last video, we covered the for loop. Before that, we learned about the if statement. So we are gradually building our programming skills step by step. Understanding our project. The shelf system. Let me explain what we are working on. We are building a shelf storage system. Imagine we have 100 shelves numbered from 0 to 99. These shelves are stored in an array in our program. Each shelf can hold one of two values, either 0, which means the shelf is empty, or 1, which means the shelf has something in it. This is called a Boolean value. Let me give you an example. Right now in our system, shelf 0 is empty, shelf 1 is empty, shelf 2 is empty, but shelf 3 has something inside it. That something is represented by the number 1. We don't need to know what the actual item is. We just need to know that shelf 3 is occupied. What we can do so far, our program could do 3 things. First, we can put something into a shelf. Second, we can take something out of a shelf. Third, we can empty the entire storage system at once. The problem we need to solve. However, there is one thing we cannot do yet. We do not know which shelf has something in it. We cannot find the next filled shelf automatically. Today, we are going to add a new feature to our program. We will create a loop that tells us which is the next shelf that is filled. For example, if shelves 0, 1, and 2 are empty, but shelf 3 is full, then shelf 3 is the first filled shelf. Our program should display the number 3 as output. Let me give you another example. If shelf 3 is empty, but shelf 4 and shelf 6 both have items, what should be displayed? The answer is 4, because it is the next filled shelf. Not all of them, just the next one. Now, what if all the shelves are empty? We need to handle this special case. I have decided that if all shelves are empty, the program should display the number 111. The number 111 will be our indicator that everything is empty, because we do not have a shelf number 111 in our system. Setting up the output variable. So that is our task for today. Let's get started. First, we need an output from our function. We need a variable to store the shelf number. I will call this variable next filled shelf. This will be an output variable. This variable is an integer, which means it holds a whole number. The default value will be 111, which indicates that all shelves are empty. If there is something inside a shelf, this variable will display that shelf number instead. Now that I have changed the interface of my function, I need to update the block call in my main function. This output variable, next filled shelf, can be displayed on an HMI screen or pushed to a data block. For now, I would just set it up as an output. Understanding the counter variable. Let me explain what happens with our counter temporary variable. At the start of the previous for loop, the counter started at value 0 and went all the way to 99. After the for loop finishes, the counter value is 99. Before we start our while loop, we need to reset this counter back to 0. If we don't do this, the counter will already be at 99 and our loop won't work correctly. So, before entering the while loop, always make sure your counter value is at the starting value you want. If you want to start at shelf 5, set it to 5. In our case, we want to start at shelf 0, so we set the counter to 0. Creating the exit condition. Now let's create our exit condition. we check if the shelf at the current counter value is equal to true. If this is true, then we will execute some code later. This will be our exit statement, where we end the loop. For now, I will comment out this section. We can add a comment section by selecting the code and clicking Insert Comment Section. This makes the code turn green and adds special brackets. The commented code will not be executed, but we will need it later. Building. The while loop. Now let's create the while loop. I can click on the while statement and it will be automatically added to my code. The while loop structure is simple. While a condition is met, do something. We will need our if statement inside the while loop later on, so I will prepare for that. But first, we need a condition for the while loop. What should this condition be? We want to look through all the shelves from 0 to 99. We want to check if there is something in shelf 0, then shelf 1, then shelf 2, and so on, all the way to shelf 99. So our condition is this: while our current shelf counter is less than or equal to 99, keep looping. Actually, let me make this simpler. While the counter is less than 100, keep looping. This means the same thing. Right now, you will see a red underline under the do statement. This is because there is no code inside it yet. If I add just a semicolon, the error goes away. Testing for the endless loop error. Let me test this now. I will add a test variable to show you what is in the counter. I set my test variable equal to counter temporary so we can see the value. Now I will download the program, but wait, it should not work. There is still an error. Let's see what happens. When I try to compile, I get an error message that says, endless loop detected. Let me explain what this means. The while loop checks if the counter is less than 100. The counter starts at 0, so yes, it is less than 100. The program goes into the loop. But what happens inside the loop? Nothing. The counter stays at 0. So the loop checks again. Is the counter still less than 100? Yes, it is still 0. So it goes into the loop again. Nothing happens. It checks again. The counter is still 0. This will loop forever because nothing changes the counter value. This is called an endless loop and it will crash the program. Incrementing the counter. To fix this, we need to increase the counter value every time the loop runs. Every iteration, every cycle, we need to add 1 to the counter. In most programming languages, you would just type plus plus. But in SCL, we write it differently. We write counter temporary plus equals 1. This means every time we go inside the while loop, the counter increases by 1. If we wanted to check only every second shelf, we would use plus equals 2. For every third shelf, we would use plus equals 3, and so on. But we want to check every shelf, so we use plus equals 1. Understanding the loop behavior. Now let me download the program and test it. I need to reinitialize because I changed the database structure. Let's go online and check. My counter temporary is currently 100. Why is it 100 and not 99? Let me explain what happened. The counter starts at 0. It checks. Is 0 less than 100? Yes. So it goes into the loop and adds 1. Now the counter is 1. This continues. When the counter reaches 98, it checks. Is 98 less than 100? Yes. So it goes in and adds 1. Now it is 99. Then it checks. Is 99 less than 100? Yes. So it goes in and adds 1. Now it is 100. Then it checks again. Is 100 less than 100? No, it is not. So, the loop exits. That is why the final value is 100, not 99. As soon as the condition is not true anymore, we jump out of the loop. Be very careful with this. If we tried to check shelf 100, we would get an error because array element 100 does not exist. We need some experience to get this right. It took me a couple of weeks and many tries to understand this correctly. Implementing the if statement. Now, what do we want to do inside the loop? Let's use that if statement we prepared earlier. I will delete the commenting section. The if statement checks if the current shelf is true, meaning it has something in it. We loop through all 100 shelves. If the current shelf has something in it, what do we want to do? We want to say that the next filled shelf variable is equal to our current counter value. But before we enter the loop, we should also set the next filled shelf variable to 111. This catches the case where no shelf is filled from a previous cycle. We use 111 because it is not a valid shelf number. Testing the program. Let's download and test. Right now, we are at 100. This is strange. All shelves are empty right now, so we should see 111, not 100. Keep in mind, 111 is our empty case indicator for now. So let's test by putting something in shelf 3. I can do this using my data block. I see all the shelves are currently false, meaning empty. Let me select shelf 3 and put something in it by setting it to true. Now shelf 3 has something in it. What should we see? We should see that the next filled shelf is 3. But wait, let me check. Oh, I see. The selected shelf is currently 3, and there is something in shelf 3. Good. Let me try shelf 7. Yes, shelf 7 is showing as the next filled shelf. But there's a problem. Let me put something in shelf 3 and shelf 94. Right now, it shows 94, but it should show 3, because 3 is the next filled shelf, not 94. The problem: finding the last shelf, not the next. What is happening? The loop goes through all the shelves. When it finds shelf 3 is true, it sets next filled shelf to 3, but then it continues looping. When it finds shelf 94 is true, it sets next filled, and it continues until it checks all shelves. So we are getting the last filled shelf, not the next filled shelf. We need to fix this using the exit statement. The solution is the exit statement. When we find a filled shelf, we want to immediately exit the loop. We don't want to keep checking. So inside the if statement, after we set next filled shelf to the counter value, we add the exit command. Exit means jump out of the loop immediately. Jump to the code after the while loop ends. This way, we will only get the next filled shelf, not the last one. Let me download and test. Now it shows 3. Perfect. Let me explain exactly what happens. The loop starts at 0. It checks shelf 0, which is false, so it doesn't go into the if statement. It adds 1 to the counter. Next, it checks shelf 1, still false. It adds 1, then shelf 2, still false. It adds 1, then shelf 3. This is true. So it goes into the if statement. It sets next filled shelf to 3, then it hits the exit command. Exit means don't continue the loop, don't add 1, don't check shelf 4. Jump out of the loop immediately. So we exit the loop with the next filled shelf equal to 3. This is exactly what we want. The exit statement is very important for controlling loops. Handling the empty storage case. Now, the last thing. What if all shelves are empty? We wanted to display 111. Let me empty all the shelves using my empty storage function. Now all shelves are empty. What do we see? The next filled shelf shows 110. That is the default value we set at the beginning, but I want 111 to indicate empty storage. Let me change the default value from 110 to 111. Now 111 is our error code for empty storage. If the loop never finds a true shelf, the variable stays at 111. I can also delete the test variable now since we don't need it anymore. Adding a Boolean output. One more thing. Let me add one more output variable to practice the if statement again. I will create a Boolean output called shelves empty. This will be true if all shelves are empty, and false if any shelf has something in it. After the while loop, I add an if statement. If my next filled shelf equals 111, that means all shelves are empty. So I set shelves empty to true. Else, in every other case, I set shelves empty to false, because then we have something in storage. Now we have feedback from our function that tells us whether all shelves are empty. Let me download and test. I need to reinitialize because I changed the interface. Now it shows shelves empty is true because all shelves are currently empty. Let me put something in shelf 94. Now it shows next filled storage is 94 and shelves empty is false. Everything works exactly as intended. Important warning. 1. Very important warning. Be very cautious with your loop condition. If I had written less than 101 instead of less than 100, what would happen? The loop would also check shelf 100, but we do not have array element 100. The program would crash. The PLC would go to stop mode and show an error. Everything would be bad. So always be careful with your array boundaries. Conclusion. This video is now almost 25 minutes long. Sorry for going on so long, but I hope this was helpful. To summarize what we learned today, we learned how to use the while do loop. We learned how to use a counter variable. We learned about the exit statement to break out of a loop, and we learned how to find the next filled shelf in an array. By the way, there is not just the exit statement, there is also a continue statement. I will cover that in a special video just about the continue statement. But for now, that is more than enough in one video. If this was helpful, leave a like. Do not forget to subscribe. I am sorry for going on so long. I will see you in the next video. Have a nice day, and bye-bye.